Yeah, cool. We're recording. And so basically today I wanted to do a system design of Twitter, right? I think we already did that. We did about 70% of that, and I want us to like go a little bit deeper into it, try to understand, an app at the scale of Twitter. How does it kind of, handle things like Twitter operates on a very large scale, right? There's 500 million writes that are happening, 500 million tweets that are happening per day. So we need to handle that kind of load, right? So I'll discuss a bit about the agenda. The agenda is to discuss some basic services, to understand the scale at which Twitter operates and how we can build something like that in a reliable way, and then discuss things like, rate limiting to prevent scraping. Like, recently Twitter came up with their rate limiters, right? So that scraping, like when you're scraping Twitter, right? Like people were scraping Twitter from different bots, so they had this rate limit that with normal accounts you cannot scrape that much because people were building accounts and scraping them, right? So the agenda is also to understand that how this Twitter system design that we are going to do is basically have some commonalities with some of the other system design that we have done. So we'll get started, right? So some functional requirements are there, and then there's non-functional requirements. We'll have a read through that as we are doing the system design of Twitter. So let's just say there's this user, right? The first thing that the user does is goes to the front end, right? And then there is this user management and auth service, right? This is something that we already discussed, right? So can any one of you tell me what this user management and auth service does? Hello?
Basically, it will create user and it is there for authenticating user credential also.
Yeah, exactly. So it basically creates the users and it authenticates. I'm just going to write it down here, right? So this functions of this service could be like creating a user. So it exposes an API for creating an user, and does the SSO or whatever kind of auths there is, like email logins and stuff like that. And so for let's just say you have an email authentication, right? So for OTP, which one of these services will you use? Can you guess, Shweta?
Notification.
Yeah, exactly. So notification service comes in handy whenever you have SSO or auth. You are going to send that to the notification service, and then that's going to send that OTP to this user service. And notification can also be used for a lot of different purposes, but basically we understood that it's used for creating an user, SSO or email and stuff like that. It might also be used for keeping some of the user meta information about the user, right? Then let's go a little bit deeper, right? Let's try to understand some of the other services, like recommendation service, right? This is a service that I created that is basically going to recommend what the user is going to see, right? So think of it, right? I'm just writing down what this recommendation service does. It creates a user recommendation feed, right? It creates a recommendation feed. So it needs this meta information, right? This is the second service that this user is going to hit. So on what basis do you think that which services do you think this will interact with to create the user recommendation feed, right? Like I'm telling this for you. So it needs to interact with the interaction service, right? What this interaction service does, it creates it's basically, you can also say it's a user history service. So it basically maintains that these are the tweets that the user has interacted with, right? He has liked this tweet, he has shared this tweet. So based on that, this recommendation service is basically ingesting all that information, and based on that it is creating, it also ingests from the user management service, right? So it ingests from these two services. If I have to create an arrow, I can show you. So right now we are discussing on a microservice level. Then I want you to handle traffic, so we'll be discussing on a deep dive level, like how we are going to distribute the database. But again, as you know, Twitter is a very big service, so the point is to understand things, right? It's more to have like a 60-minute fruitful discussion on a system design of Twitter rather than trying to design Twitter in itself, right? So when you think of a recommendation service, it is basically going to take stuff from both the user management and auth service. It's also going to take stuff from the interaction service, which is also a kind of a subset of user management service only. It basically stores where the user has interacted with, right? It basically stores the user behavior. Then it can also take info from the tweet service, which basically says that what are the tweets that have been what are the tweets that are happening, right? It basically stores the tweets, right? All tweets across all people, like you have Justin Bieber tweeting, you have your average Joe tweeting, anyone tweeting, all of that stores in the tweet service, right? And like I said, analytics service is kind of the commonest things, right? Shweta, can you, or someone else, can you tell me that what this analytics service is going to hook up to in all these services? Which ones can this analytics service listen to?
Tweet.
Tweet, but it will also listen to other services, right? Think of it like Hotstar. We are just
Yes.
doing, yeah. Which one? Which other services are
See
there?
it. So I think so. It will be for tweet first of all, and then for interaction
Okay.
and
Any other service?
search service also. Like what are you searching? That is also like will give us a good analytics.
Definitely, definitely. So every action that the user takes here, right? Every action that they here takes, apart from the user management, maybe the recommend not the recommendation service, but even the notifications that are being sent. The timelines, the search, the tweet, the interaction, everything is basically going to be ingested by the analytics service. It's going to be used in various different formats and ways, right? But everything is information, right? If I tell you how to build this search service, right, what's a tool that we have already discussed, right? A very simple thing that all these tweets go in somewhere. There's tweet service, right? You're basically just searching, right? So it's a direct all the tweets are just going to go. Is someone else joining? Yeah. Okay. So all the tweets, right? All the tweets are just going into the search service. It's going to be dumped using some tool. If I have to build this search service, this is a tool that we have already discussed. What is it? Something that we are going to use? Hello.
Elasticsearch.
Exactly. We already covered this, right? So we dump all the tweets into Elasticsearch. Elasticsearch is scalable, right? It can figure out sharding by itself, and we just dump billions of tweets there, and we can search it easily, right? Again, there are optimizations in Elasticsearch, but again, that's not the topic of here, right? Right now we are discussing on a microservice level, right? Then we discuss this analytics service. Tweet service is basically just going to store all the tweets in that format, right? Then we have something like a timeline service, right, for a user's timeline, right? What tweets he has done. So everyone's timeline could be stored here, right? Again, you can have hundreds of services like this, right? So this is a basic microservice level architecture of Twitter. Okay, now let's think of problem statements in detail, right? We are going to think of things like how does Twitter handle this kind of loads, how are we going to distribute stuff, right? Let's talk about some of the non-functional requirements. Okay, let's just understand if we covered up all the functional requirements: user registration, authentication, user management service. Okay, user should have the option to log in via social media account. Again, user management service, like we already discussed, SSO or email. You are basically just going to return a UUID, right? I'll write it here, right? Once the user has logged in, you return a UUID or a session token, right? It creates a long-lived session here on this device, and everywhere else where the user has to interact with it, just goes through there is a login endpoint here, right? authenticate endpoint here. So all calls just basically pass the session token, and from here it passes the UUID and all other services that the user interacts with. Like he has to, user must be able to create, read, and delete tweets, right? So basically just the tweet service he wants to. So again, one more thing when we are talking of this, right? In the cap theorem, right? We talk about cap theorem, and there is a distributed system, right? Cap theorem. So C stands for consistency, A stands for availability, P stands for partition tolerance. We already talked that P cannot be there. It's either a CP or an AP system, right? So because partition tolerance is always has to be accounted for. So it's a CP system or an AP system. So based on our discussion, what kind of system is Twitter? Is it a CP system or an AP system? Hello?
AP.
It is an AP system.
Yeah, exactly, because all social media platforms are AP system. Your rights don't need to be eventually consistent, right? So whenever you have to write something, what are we going to do? We are going to insert a queue here. There's a queue. Okay, the elements are a bit message queue. Let me search. Yeah, let's just say this is a queue, right? So whenever Twitter has to whenever you are updating a tweet, right, what it does is it puts it in this message queue, right? I'm just going to put it like this, right? Tweet service stores your tweets. So whenever you have to create or update a tweet, it goes into the message queue, and then that goes into the tweet service, and with it is basically stored with your tweet ID, right? Now again, some concepts that we discussed earlier that are again going to come into the picture, right? So you're seeing how everything is linked up to everything, right? You system design something, you system design the other things also. So let's just say, so whenever you have to create or read a tweet, it's basically just going to be it's going to be a call to the queue, right? Create or update a tweet, right? So it's basically just going to put that tweet into the queue, and then it's going to go to the tweet service, and then it's basically just stored in that format, right? ID and UUID, right? But what if your tweet contains images, right? What if that contains images? How do you account for that, right? So images need to be near the user, right? So this is something that we already discussed. Whenever you have something that is about images, files, and all that stuff, you are going to take a CDN, right? And in case of a microservice, we can call it like an object storage, right? So let me talk this mechanism a bit again, and I think this is something that you guys should be pretty familiar by now. You create or update a tweet, right? The tweet has some information, it has some images. So what the format that we will be doing here is basically it's going to be a tweet ID, right? And then within there it can be the message, and then for images it will be an image ID. So what this does is it's going to put that image in the object storage. From there it's going to be a different mechanism to understand where the tweets target audience is, right? This object storage can talk to your let's just say interaction service to figure out who the target customer of the tweet is, right? And it's going to put that in the CDN that's nearest to that customer, right? If some Indian celebrity is tweeting something, right, and the target audience is in India, so what this object storage will do, it's going to talk to that interaction service. It's going to basically figure out that the target audience is in India, and it's going to put these objects, image IDs, in the CDNs of India, right? But at the scale of 500 million, you can understand that even this meta information has to be cached, right? So we are going to discuss that as well, right? So but this is something that we already discussed, right? Object storage. Is this also clear to you guys?
No, so it's a kind of a microservice,
Yeah,
or
so
as I'm Okay.
again, it can fall as a part of the tweet service, right? So like I said, that Twitter is very big, right? You can there are not 5 7 microservices, there are like hundreds of microservices probably within Twitter, right? So this is just the object storage. You can think of it, there's CDNs that it's, connects to.
So base.
Yeah.
So
So
basically, it is for persisting the data, right?
No. The object storage is a CDN basically. So, like I said, you have a tweet, right? You have a tweet you are writing. With what does a tweet contain? A tweet contains some message, and it contains some images, right? Now the message is small. It's 1 KB of size, right? It can be stored in any server. You can store it in North America server, and then you are accessing it from your India, right? And it's still going to be very very fast, because it's 1 KB, right? How much time will 1 KB take to travel? But if it's an image, it's in MBs, right? So there's going to be buffer, there's going to be lag. So if you have to deliver it to your user in a reliable manner, you always have to use CDN. This is something we already discussed. You have to use CDN. So always when there is image and stuff involved, you always create a separate microservice or something like that, right, for dealing with specifically images. And what this service is for, right, what it does is you dump an image inside it, right? You dump an image inside it, and it's going to give you an image ID, right? And but here in the case of Twitter, this object storage needs to have a bit more context. And why does it need to have more context? Because it will be very helpful if this object storage actually knows that, under which CDN I'm actually going to dump this image all. Because like which CDN, which servers or which region this tweet is supposed to be consumed the most in, right? So it's going to take that image into that CDN. So this can also talk to the tweet service, the interaction service, and figure out, and also the search service, right, which searches have by previous history data to figure out that which CDN I should put that data in, right? This part is clear, right?
Yes, yes, this part is.
Yeah,
Ramit, there is my doubt. We have two regions like India and America,
okay.
and we have dumped the images in one CDN or two CDN based on region.
One CDN or two, there's no one CDN or two CDN. There's CDN is a globally distributed, like Cloudflare, right? It's globally distributed servers. There are thousands of servers worldwide, right? So depending on where the user's consumption is, you can put that tweet across every, like if Justin Bieber tweets something or Mr. Beast tweets something, the with an image, right? The demand is worldwide. Everyone wants that tweet, right? So you are going to put that image in every CDN in the world, right? You're going to put it in thousands of CDNs so that every user can access it, right? So this is something that we discuss in like every, we did Hotstar, we did other system designs, we already discussed this CDN and object storage, right? Whenever there's an image that comes, we pass that image into the CDN, we pass context of that image, that where that CDN needs to be there, and it figures that out, right? So I want this part to be very very clear to you guys, because this is something, you can spend like 5 minutes with the interviewer just talking about this, right? And which services it interacts with. So this part is very clear, right?
Ramit, one more question. Like, so this object storage will actually figure out the purpose, will serve the purpose of dumping images to CDN. That I understood, but it's a single point of failure, right? What if it goes down, or what if there is any issue with that storage, or I mean object storage? Then how CDN will get the data?
How CDN, yeah, single point of failure is not like that. So within this also, we're trying to discuss on a very high level, right? We're just discussing microservices. Single point of failure is within this, you can also always have failovers within this server, right? So when you talk about a system like Twitter, you have layers on layers on layers, right? We could spend the whole day
Okay.
discussing that, just discussing microservices and just discussing this object storage architecture, right? So we get there, right? This is something that we discussed. We have analytics service we discussed, and so this is a basic You guys understood this part, right? Feed should be updated in real time. As someone posted, it goes into the message queue, it goes into the tweet service, right? And then the, like, we have, like, let's just we try to figure out who the consumers are, then the interaction service picks it up, and then the tweet is distributed across, the feed service basically generates the tweets, right? And then we have this follow unfollow. Again, it's an action that goes into the user service, right? Let's just say it can also sit at the interaction service. We can design it in different ways, but what services do you think this follow unfollow will affect out of all these services? Can any of you answer this?
Interaction it will affect.
Yeah, it's an user
Also
interaction.
recommendation.
Yeah, recommendation, definitely it will affect, right? Because it changes the recommendation, that which user should I recommend, where should I recommend this to.
And timeline as well.
Yeah, it could have, no, timeline is for a user's timeline, it shouldn't affect the user's timeline. But yeah, it should also maybe affect, again, depends on how coupled this user management and interaction service is, but mostly the interaction service and the recommendation service, right? These two services are actually very closely coupled if you look at it, right? Searching for tweets, hashtag user profile, again, search service, right? Search results should be relevant, displayed promptly, right? If a user has blocked another user, his search results should not come. So this search service also talks with this interaction service in a certain way, right? Again, depends whether you have put it in the user service or interaction service, like where you are dumping the data, that depends on which how this search service is going to handle that, right? So we covered all the functional requirements. Now we are going to go to the non-functional requirements. Like, before that, any of you has any question around these functional requirements?
Ramit, I have one doubt regarding timeline service. You told that it is not affected by follow or unfollow. But I think if I will unfollow someone, so my timeline will not have tweets of that particular user.
Okay, got it.
Or
So I
so,
actually I actually don't use Twitter, so I don't know how that service works. I've just put it here because I just tried to get a high level overview, right? So maybe that affects. Again, I don't use Twitter. I've just noted down some functional requirements, right? So again, that's one thing. Let's go back to, is there any other questions? Hello. Okay, nothing else.
No,
Yeah, cool. So we go now, we are trying to understand, right, at the scale of Twitter, right? How do we, let's just say this is a tweet service, right? I'm going to break down this tweet service, trying to understand how we will have, our database structure, right? So let's google a bit about the number of tweets per day. There's 500 million tweets per day. We can assume that there are billions of writes that are, I would say, happening, billions of reads that are happening, right? If there are 500 million tweets that are being given out per day, there's like 5 billion reads, right? At this scale, databases need to be very carefully designed. Let's talk about this, right? So there are 500 million tweets that are being written per day, but there are always going to be more reads than writes in this kind of system, right? So this is a read heavy system, right? There's going to be read heavy system, and as we already discussed, there's going to be a you guys can complete me sometimes, right? Like, I'm saying it's going to be a, you'll say like it's going to be a master slave architecture or something like that. Anyways, so there's going to be a master slave architecture, right? this is this is the master, right? All the writes are happening in the master, and all the reads are happening from the slaves, right? So the master has a fixed amount of CPU, like you can also understand from this picture, right? So the master has a like limited CPU, right? If there's like 10x the reads happening, then I'll have 10 slaves, and the slaves are also going to be in different regions, right? This could be a slave in India, this could be a slave in US. So that way the tweets are very close by, and whenever you are writing something, as I already explained to you, following the principles of cap theorem, right, this is an AP system. So availability is not that important, consistency is not that important, right? If I update the master, the slaves can the data can percolate down to the slaves like slowly, right? It's not necessary that it needs to should, yeah, it eventually becomes consistent, the slaves eventually becomes consistent with the master, and all reads happen from the master master replica, right? So that way we handled any read issues, like we can have a billion slaves across the world, right? But at a scale of 500 million tweets, right, the master is also going to get a CPU choke. Like if you take the biggest CPU in Amazon, right, if you get an entire data center also to have like built one massive database, that will also be not be able to handle 500 million tweets. And you create a single point of failure, like when you are doing 500 million tweets, right, you can't afford that, you need to shard everything, because when you shard things, then also you have replicas. So let's assume, like, what could be a tweets, what could be the data in a tweet, right? You have the tweet ID, you have the user ID, you have the location of the user, right? What else, what other metadata can I think of? You have, if the user is a celebrity, this is something also I'm thinking of, like, is the user a celebrity, right? What is the following of the user, and why is this relevant, we'll talk about, right? So let's just say we are going to shard this table, right? Which parameter do you think we should shard this on? We already discussed this, right?
Location.
Yeah, exactly. So we shard it on location, because that's also, we can also shard it on the user IDs, right? We collect user IDs and store them together, right? So that's how sharding operates. Now I want you to think of something else, use cases, right? Use cases. The way that I can think of, like, how does a tweet get distributed, right? How does push notifications work, right? Because when you think of it, right, there are two ways Twitter functions. When a user comes to Twitter, right, when a user comes to Twitter, he gets from the recommendation service the list of tweets that he should ingest, and he gets those tweets. But you get these notifications, right? Every social media platform does this. You get these notifications at time that Justin Bieber tweeted something, or this person tweeted something, like you get these notifications, just like YouTube gives you notifications, right? So I want to talk about, right, let's just say, how does this architecture look like, right? When Justin Bieber is tweeting something, right, consider this like a person A, right? Person A, let's just say this is the person A, sorry, person, this is a person, right? This is a person A who follows person B, right? Person A follows person B, right? A follows B. Now let's just think of it, right? Let's think of it, if there are a lot of people who are following B, right? And whenever B posts something, all of these followers are going to get a notification, right? All of them are going to get a notification. And the architecture that I can think of right now on the fly, right, what happens is this: whenever A posts something, that data is going to go into a message queue, right? And then it's going to go into the let's just say there will be one more service, we'll create one, right? And that will hit the notification service and tell it that, hey, send a notification to all my users, right? So what happens when a person like Justin Bieber tweets something, right? He has 120 million followers. So those 120 million followers are going to immediately choke up the notification service, right? Hello?
Yes, Ramit.
Yeah, so they are going to choke up the notification service, because again it's going to be 120 million people. So it's a very good thing if we think of it, and we split the users in normal users and celebrities. This is something very important for an interview also. You should think like this, because this way you can handle load differently. If a normal user tweets something, you just send it off, right? You send it to the message queue, you send it to the recommendation service, it goes back, it sees that what are the relevant users, and then based on that data, right, it's just going to send out a pn, right? When it's a celebrity that's tweeting, right, if it tweets with an image, you first you first cache that tweet properly, right? Because if you don't cache that tweet properly, right, like if Justin Bieber is tweeting something, and that tweet, there is just one copy of that tweet that is stored in the tweet service in one shard, right? This database had 20 shards, it's stored in one write shard, or let's say one read shard, right? And it's stored in one object storage in North America. Can you imagine what is the situation that's going to happen when people across the world are going to read that tweet? The system's
Okay.
gonna overload, right? That this read shard is gonna overload, because millions of people are going to hit this read shard, this one read shard all at once. It's gonna choke. This object storage is going to choke. People's devices are going to be lagged, because it's every device is now hitting the North American server, finding out for that one tweet, right? So it's going to become an outrage. So whenever a celebrity tweets, how Twitter, how this system should handle it is, first it's going to figure out a distribution strategy, right? And this word is very important when we talk about social media, right? Distribution strategy, right? So it's going to figure out a distribution strategy. It's going to figure out that, okay, these are the people that Justin Bieber follows, they are across India, they are across North America. So I'm first going to distribute multiple copies of this among these servers, right? I'm going to use consistent hashing to distribute them, and also to see that whenever someone's reading it, it does not hit the same server, right? So the traffic load is also distributed. And I'm also going to make some try to do some things in the object storage to ensure that there are multiple copies that are available, right? So ensuring that there are enough food packets to feed the people who want that tweet, right? So that's the way that you handle heavier loads, right? Then we talk about the user intuitive search operations, returning results super fast. This search service will not just use Elasticsearch, it can also read from the recommendation service to try to understand that what is the making it more intelligent, right? Like what kind of tweets does this person want. How can we filter out the search a little bit, right? If we can filter this search into quadrants like P0, right? This user follow these people. If their search is relevant within this, then why go further? Why search the entire Twitter database, right? So that way we can make the search service fast, right? Ensure uptime. So I think we discussed almost all the points. We are now going to do a Q&A, right? Try to make it more interactive. So anyone have any questions? Hello?
I have some doubt in that point, like distributed strategy,
Yeah.
like using consistent hashing.
Okay.
So I'm not very much clear about it. I know what is consistent hashing, but I'm not understanding what's purpose it will serve. It will distribute it to different multiple locations, suppose in India. But
Yeah.
what about other region? Suppose like outside India.
Yeah. Again, like when I said consistent hashing, that's like a misspell kind of thing. So like what consistent hashing is, it's basically like when you add new servers, and your network traffic is being routed equally among those servers, right? So again, the distribution strategy is not like consistent hashing, but the distribution strategy is a strategy that, let's just say when a celebrity is tweeting, right, you look at his traffic, right? What is his audience, where does this audience reside, and what is the time at which his audience is going to open that what kind of network spikes is opening this tweet at this given time going to cause, right? And basically that when the user wants it, right, like when you talk about systems, like you want a Maggie right now, like Zepto has it in store, right? So they figured that out. So it's basically like the distribution strategy is like figuring these things out, right? And based on that, you are going to take that tweet, and if it's in India, then you put it in 20 servers in India, because people in India are going to want it, right? If it's not that needed in South America, then you don't put it in South America that much, right? So it's basically like that, when someone wants it, he can have it. It's somewhere near to him, and it's also not choking up a server, right? That's how, because a normal person cannot choke a server, right? He makes a tweet, it's read by 5-10 people, but for celebrities you need to be careful, right? If you put it in one read replica in one zone, then it chokes a server, right? So before you distribute the tweet also, before you put it in the recommendation service also, you need to be careful about your distribution strategy. Does that make sense?
Yeah.
Yeah, totally. So I think that's great. I mean, if you are able to do this, right, break this into microservice. Yesterday we did that completely ad hoc, right? We did about 70% of it, we unprepared completely. So if you are able to do this, that should be good, right? So, uh, like, do you guys feel like confident, right, after this, that you guys might be able to, like, you see, we are reusing a lot of things. We're reusing the analytics service, we're reusing the search service, the object storage, this thing, right? Read write master replica, right? Queues, these things are being reused. Notification service is being reused, user management service is reused. So you guys can understand, right, where are you putting these pieces together, right? Hello. Okay. Okay.
Yes, Ramit.
Yeah, yeah, I expect you guys understand. So yeah, any feedback on the class or anything, right? Or like, do you guys have any
I
questions?
have one question.
Yeah, sure.
Yeah, I have one. So suppose whenever a celebrity tweet, we'll cache it, right? For I mean, fast latency or fast access, you can say. But till how long will cache it? I mean, there will be lot of data in the cache CDN, right?
Yeah.
So like there will be images, there will be static pages, there will be messages. So like I'm not understanding till how we will cache it, because for future purpose we'll have to persist the data also. Like in future, if anybody wants to go and see his or her post
Yeah.
or tweet, they should be able to see it.
Yeah, exactly. So whenever we talk about cache, right, there's just one simple term that you can use, which is TTL, right? Time to live. You know. So whenever
Mm.
you are caching it, right, if you see, the life of a social media post is 1 to 2 days, right? So if you cache it for 2 days, that's good, right? Because after that, whenever someone wants to reference Justin Bieber's tweet, he might not find it in its local cache, right? He would have to, he can hit the servers. There's no risk of choking then, right? I mean, the data is already stored at a central location, right? It's also distributed, but that is the basic strategy, right? Whenever you're caching it with the TTL,
Mm.
right? So
Okay,
no.
I have one more question. Like, there are suppose multiple tweets,
Okay.
okay, and like tons of tweets, and as you said, we'll use message queue, right? So,
Yeah.
message queue will not give the persistent, doesn't have a persistency facility. It always database who persists the data. So, at what point of time the data will go and sit in database? Because uh, database has low throughput,
Yeah.
right? So I'm not understanding this bulk messages what everybody will be tweeting. At what point of time it will sit in database? Are
Yeah.
we doing any bulk right in
Totally.
one go?
Yeah, yeah, yeah. So when I talk about message queue, the purpose of message queue is not to choke the system, right? Now to get your answer right, you need to think of it like how does it happen when you're writing a post, right? Like when you're writing a post on LinkedIn, right? You write the post and then you hit the post button, right? So have you seen that when you hit the post button it takes a delay?
Yeah, yeah.
Exactly, right? And when you're doing an object, how long is the delay when it's an image and when it's a post?
So image will take little time.
Yeah, exactly. So what do you think it's doing in that time? Like I'll tell you something, right? When I was a person with like 1k followers, right, and I would post, my image will get posted very fast, right? When I hit the post button, right, image will get posted very fast. When I'm right now at like say 25k followers, right, when I'm hitting the post button the image takes a lot more time. So what it does is it's actually figuring a small distribution strategy if you think of it, right? LinkedIn does not do that much, but it's also doing like how many people am I going to show this image to, right? And it's caching it in those layers, right? Maybe some people in North America it's going to show this to, so that's why it's taking time, right? When a bigger user like someone like more popular with 100k followers is going to tweet, going to post on LinkedIn, his post is going to take more time because it's that caching strategy, it's going to cache it into more areas, right? So it's more accessible. So you do understand this part, right?
Yeah, yeah, I understand this part.
Exactly. So it's all in the details, it's all in the in your real world, right? All answers to all your questions are when you open your phone, you tweet, you decipher that behavior, right? And you will be able to understand what's happening behind the scenes. The purpose of message queue, that delay, is so that at one point of time, like if something happens like IPL or something happens and a lot of people are tweeting, right, it's going to choke up the system is going to overload, right? That is what it's supposed to save, right? In general it's supposed to the message should be in message queue for 1 to 3 seconds, right? During that time when it's buffering, and when it is posted, then it's already out of the message queue, it's already stored in the database. Okay.
Okay.
Yeah. So any further questions? Nothing. Okay. Any feedback or anything, like anything you want to talk about? Okay. Okay. I guess I'll stop the recording then.